Hey, so we're going to end our year um, talking about environmental awareness, um, consciousness that you have a world around you. You are in the middle of things going on. You cannot separate yourself from these things going on. You and the earth are indistinguishable from each other. So whatever befalls the earth also happens to you. You don't have any options. Nature is in a constant process of finding and adjusting balance. So let's talk ideas in balance. Well, equilibrium. Equilibrium is a state of balance. So the water in a sealed container stays there. It's in equilibrium with itself. Nothing is changing. If you come back a year later, it's still the same water. Everything is the same. Dynamic equilibrium is similar. It's a changing balance. Now, how can that be? Well, think of a lake. The water level in a lake is constant, but water is flowing into and out of the lake, so the water is changing, even though the level stays the same. Think of your blood sugar. It's the same pretty much all the time. It's supposed to be. Your cells take up the sugar, your body, your digestive system puts the sugar back in place. So, how does pollution fit into things? Well, pollution is anything, any material substance or a form of energy that is harmful to the environment or living things. Anything, anything at all that is harmful to living things in the environment, we would consider pollution. It's a very broad definition. So what happens though is that nature will adjust to pollution by going through other changes. These other changes can have other unintended negative effects. So pollution is not just a one impact, it ripples throughout the environment. So let's think types of pollution. So there could be natural or people-made pollution. It doesn't have to be all people pollution. Nature, of course, has tremendously polluting events built right in. The first probably comes to mind is a volcano, right? And then maybe smoke from forest fires. Pollen, invasive species can be a naturally occurring thing, or of course people now are the cause of a great many invasive species events. Chemicals, people tend to be more the cause of chemical spills and such. Heat, and thermoelectric plant or a plant that uses thermal energy to generate electricity will very often have to release a great amount of heat into the environment. Noise is a tremendous pollutant if it affects some community and causes some disruption in it. You can imagine in a swamp, an airplane passing low over it might cause all the frogs to stop making their noise for mating. And it might be that they're on an airplane route often enough that it changes the whole cycle of mating. So noise can be a great contaminant. In fact, a car passing, waking you up in the middle of the night and you not getting back to sleep, well, isn't that pollution in that event? And light, the urban area can be so full of light as to disrupt native species. So what components of our world are affected by pollution? Air. All biological components, or most of them anyway, have some business transactions with the air at all times. So if the air is polluted, some of that pollution will pass into the biological communities. Similarly, with water, the same thing will always occur. When you drink water, you're drinking everything in that water. The ground is a great repository of all these chemicals. Plants can take pollutants directly from the ground, but the ground then can leach these chemicals into our groundwater. So eventually, many of these chemicals will find their way into our crops and thus our own beings. And if it's not getting into the crops, it certainly may be getting into the drinking water. Uh, Pollution affects pretty much everything. It gets into all things. So we would look at this and think of that as a major source of pollution, and indeed we may be correct. Very often, those smokestacks, the bulk of what's coming out of them is just steam, condensed water, but there may be other things in them as well. So the other things in that may contribute to smog, which would be when smoke carrying particulate matter and sulfur and things like that meets sunlight and water, it reacts. And the reaction creates something we call smog. And it was noticed in cities early on. And it's a nasty fog. It's like a very foul smelling fog. One of the biggest concerns we currently have is the carbon dioxide given off, as well as other gases that are given off. They trap the Earth's energy. Once we've heated the Earth up, now the Earth wants to cool off by radiating infrared light back to space. So long wavelength infrared light is sent off into space from Earth. But these gases, carbon dioxide and methane especially, they aren't transparent to infrared light. So infrared light, they absorb and they become warmer. So they radiate some of that heat back down and they change the whole heat balance of the Earth. We call that the greenhouse effect, and it's starting to have substantial effects upon the Earth's environment. One chemical that's a goofy chemical, low down here, ozone, which is three oxygen atoms put together, is so reactive that it's made by a lot of processes, but it's so reactive if you breathe it in, it's like tearing you up. Now, fortunately, you're not breathing enough in for it to kill you, but it's not doing you any favors either. So in the lower atmosphere, ozone is bad. And generally, all that ozone that we produce reacts with other stuff and breaks down right in the lower atmosphere. However, we also make another class of chemicals called CFCs, chlorofluorocarbons. And these chemicals, when they don't react with anything, that's why we like them so much. So we fill our refrigerators with them. We use them. We used to use them in our spray cans. We banned them pretty much. But these chemicals didn't react with anything until they got very high into the atmosphere, when they would start meeting a large amount of ultraviolet light. Now, they would meet ultraviolet light in the ozone layer, where the ultraviolet light is being destroyed. So a lot more of the ultraviolet light is present the higher you go in the ozone layer. And when the ozone layer hit these chemicals, it could destroy them. Those chemicals would release chlorine. That chlorine atom then could destroy 100,000 or so ozone atoms, apparently. So the ozone layer that protects us from the ultraviolet radiation was being badly destroyed by CFCs. We banned them, and the ozone layer started fixing itself. It may have stopped fixing itself because of the greenhouse effect now. And that may be another problem with the greenhouse effect, but stay tuned. So when we think of air pollution, we think of things like this. And of course, we're absolutely usually quite correct that while a lot of that is steam, a lot of that is also stuff you would really not want to live downwind of. But there's a whole other kind of air pollution that may affect you if you live in a more rural area apart from any cities. Look at this. If that's a site that's recognizable to you, and I suspect it may be if you live in a rural area, you know of it as a burning barrel. So let's talk about burning barrels. Burning barrels release large amounts very large amounts of dioxin at much greater levels than would an industrial incinerator burning huge amounts of garbage right next door. One burning barrel releases more dioxin than that. The reason is the industrial incinerator burns at tremendously high heat. It would break up these dioxin chemicals. When somebody burns in a burning barrel, it's very, very low heat. All these odd chemicals are simply released into the air. Dioxin is among the worst of them. It's a long-lasting carcinogen that makes its way into the food chain. So even if someone is burning garbage someplace where it doesn't feel like it's in your air, that dioxin is landing and it's getting quickly into your food. So we are getting dioxin levels even if you don't live downwind from a burning barrel. But if you do, you're getting more dioxin. So not only do burning barrels release dioxin, they also release large amounts of smoke, all sorts of individual smoke particles of widely varying sources. They release lead into the environment. They release mercury. They release arsenic. These are not good things. Burning barrels are kind of the scourge of our land. We often wonder why so many people in such beautiful rural areas end up with so many cancers. You may not have to look any further than the burning barrels because the chemicals they release get into the groundwater. It's a great point source for huge amounts of serious pollution in rural areas. And additional air pollution concerns, things like acid rain, the sulfur and nitrogen oxide from distant factories and power plants can form this acidic precipitation. And it's not tremendously acidic compared to natural rainwater, which you know has carbonic acid and is ever so slightly acidic. But this increased acidity, it changes the pH of entire lakes. And if those lakes don't touch, say, some kind of rock like limestone that could alter the pH favorably, it could kill pretty much all the life in these lakes. So acid rain is of great concern. Not in all areas, but where it does damage, it can wreak serious damage. You also have just particulate matter, dust, other small pieces of materials that are damaging. If you think about working with various industrial processes that release, say, tiny, tiny vaporized bits of metal, okay, so you're being safe and you blow that stuff outside. There you go. So we now have these tiny bits of metal moving about in our air. Not so good. Smoke, just in general, there's such a wide range of chemicals released into the air from smoke. And as I said, our worst local air polluter are burning barrels. So if we think about water pollution, the things that very often hurt water, oil spills. Entire tankers have run aground and spilled their oil and have done significant damage. A large amount of oil getting spilled seriously has a broad impact on the ecosystem, and we do not know all of the impacts. It does appear that cold water is a much longer lasting disaster than warm water. Chemical spills, similarly, there's so many different chemicals that can be spilled and can linger in the ground over long periods of time, and what their effects are very much dependent on what chemicals are there. Acid rain, as we said before, causes problems in the water. One of the other things that could get into the water from industrial processes is mercury, which in even very small amounts is very, very bad for living creatures. Lead, similarly, does not take much lead. There is no safe exposure of lead. They consider any lead in the environment is bad for you. But then we have some non-point source pollutants. And by non-point source, we mean areas, huge fields, where it's not a single place that's giving this off. And you can imagine if you're in agriculture, manure is spread over a very, very large area. Fertilizers, similarly, spread over a very large area. And pesticides as well would be very large area. And all of those, as they leave that area, they leave over a huge swath of land, and they get into the streams generally. One of the things these non-point source pollutants cause um, are very often these algae blooms, where the pollutants are emptying out into a river from all these agricultural areas. And they have a broad impact on what happens in the ocean. They cause the ocean to get seriously out of balance. A lot of algae blooms. When that algae dies, bacteria consume it and use up all the oxygen and completely impact the life over the entire lake or marine area. It just doesn't look good. You would never want to see something like that emptying into your drinking water. But remember that you have to test things before you know. That might just be sediments and otherwise mountain clear drinkable water. You have to test them. Unfortunately, our scientists are very good at testing water. And if a tanker should go down, there's so much oil there that's going to come up and float and do severe damage to all the aquatic ecosystem in that area. And again, it will get over it at some point, but it will change the area, thus being a pollutant. It might destroy it as a fishery for a long time. It might have an impact over an even longer period of time. The oil was not there initially, so it changes things. If we talk about ground pollution, Um, one of the first things that could go when you think about ground pollution is just heaps of trash. You totally ruin a piece of ground with trash on it. But not only does it ruin the piece of ground, as water, because it rains on it, as water goes through it, leachate, stuff leached out of it, goes into the ground and will work its way down, of course, to the groundwater. And that produces groundwater contaminations, and it literally poisons the water you drink. It doesn't necessarily take a lot of chemicals to cause you trouble, and you wouldn't necessarily even know what's causing you trouble. Um, if you have various pollutants on the ground, um, if the water has either runoff or infiltration, either one, however the water passes through it, it's going to carry the contaminants down to water that somebody cares about. It might be the stream running away from you that provides an aquifer for somebody to drink way downstream, as very often around my region it does. Um, but it will simply infiltrate down to your groundwater as well. Sometimes material is buried with the idea that once you bury it, then it's not a player anymore. But of course, that material leaches into the environment over time as well, without serious boundaries. Sometimes mining will displace harmful minerals that were in the ground and were not really playing a role, usually, in the way things work in the groundwater there. But now you've displaced them through mining, and they cause much more trouble. Sometimes, though, minerals simply in the ground can make groundwater bad for you. When you make a landfill now, you have to line it with multiple layers of a thick plastic to hold the landfill, to hold all the juice that comes through that and process all that to keep it out of the groundwater. But if some of the landfills, especially the old ones, leak, whatever they're leaking will contaminate the groundwater. You can see a lot of this is all about groundwater because that's the water we drink. That's the water our children will drink. And we have at times done great damage to the ground. You can imagine where do you even begin to clean this up? So energy also releases pollution, just the production of energy, waste heat from power generation. Any power generator, it needs to cool itself. It tries to use as much of that heat as possible to make the energy that it sends to you, but then it has to cool the rest off and releases a lot, usually, of hot water into the environment, and that can change the environment. Radioactivity, just mining for the uranium we need, releases low-level radioactivity to the environment. And of course, any nuclear power plant failure can release tremendous radioactivity to the environment. Although it generally does not kill a great many people, it can completely devastate a small environment around it. Small meaning a couple miles across diameter. But we could probably have worse reaction disasters than we've had. Light pollution. Whole cities are lit up. When you look at a space picture, there are so many lights around New York City. It appears as a huge dot. If that changes the nocturnal behavior of animals, and it's hard to imagine it doesn't, that would count as pollution right there. Sound pollution. A lot of noise disrupts the local environment. Any disruption is a type of pollution. And by that, we mean the local environment is forced to adjust to that. Sometimes it can, sometimes it can't. Some species can adapt easily, some species cannot. Okay, well, that just kind of looks almost scary, doesn't it? But those, in fact, are not releasing any pollution at all, really. They're cooling towers for radiation plants, for plants that use nuclear power. But they're not radioactive themselves. There's no real danger from them. They just release condensed water, little clouds of steam. Well, there's light pollution for you. There's the USA at night. You can see New York City looks like a dot, but there's dots all across the country. So if that disrupts nighttime creatures, you can imagine it. There's a lot of disruption going on. A fundamental reason why pollution is such a problem really has to do with the amount of people doing the pollution. If it was a very small group of people living on planet Earth could absorb and deal with it much better. But the population explosion means extra people need extra resources. So do we have enough resources already for the present? Well, an awful lot of people are living at poverty's edge, just barely surviving. So our resources already are stretched. Now we could reallocate them better, but we are apparently pretty close to the limit of what the Earth can easily support. So do we have enough for the future has a lot to do with how many people are we talking. If we double the population, we might not have enough for the future. So the population explosion, clearly, whatever ills the human race causes, more of them cause more trouble. So what are the effects of overpopulation? Increased pollution, increased strain on resources. It makes it more challenging for everybody. So in general, the more crowded, the more polluted. You can imagine if there is one house on a lake, that is more polluted. That lake is more polluted than if there were no houses. But it's probably so slightly polluted the lake can handle that without any substantive changes. But if there's 10 houses, it's much more polluted than from one house. And if there's 100 houses, more than 10 houses. At some point, the lake cannot handle it without having some more substantive changes. Now you have a dangerous combination: climate change and overpopulation. Huge populated areas are becoming unlivable. They're becoming so challenging to live in that people have to move. And you already have the world overpopulated. So global climate change involves millions, if not billions, of people ending up migrating and to already very populated areas. There's serious problems associated with this population explosion. So when we talk resources, renewable versus non-renewable, renewable is replenished as fast as it's used. For example, wood, air generally, water, these are replenished as fast as they're used many places. Non-renewable are not replenished as fast as they were used. Minerals are not replaced as fast as they were used. Fossil fuels, um, soil is not replaced as fast as it is used. And one could argue in many places we have to switch water to the other column because water is used up faster than it's replaced. So water is not by any means a renewable resource. It depends on where you live, really, doesn't it? Here's a little story. My friend Paul. So we learned that in general, a rule of thumb is you could take a cord of wood, every acre of forest, it'll leave the forest unchanged. In other words, there's enough trees where if you cut a cord of wood from an acre of a forest, an acre is a good amount of forest, you could take a cord of wood from that every year. The forest doesn't care. The forest is the way it is. There's fewer standing dead trees, maybe, but the forest remains unchanged. So my friend Paul had 10 acres. He took 10 cords of wood to heat his house for the year every year. From those 10 acres of woods, he got 10 cords of wood to heat his house. One year he wanted to sell some wood, make up for a little loss. He wanted to sell some wood. He took 15 cords of wood. Then he went back to just heating his house again, taking only 10 cords every year again. Shouldn't be a problem. But soon he had cut all the big trees. He still needed wood, so he cut the smaller trees, but it took more of them to make the same amount of wood. Each year he needed to cut smaller and smaller trees to make his 10 cords. After some time, he had no woods left. The point of that is that once you put a system off balance, it changes. That's what happens. It changes. So think of ways to protect resources. When we were placed with alternatives, there's often alternative resources we could get. So we could swap one thing out for another that is easier to get, less harmful on the environment, maybe biodegradable, maybe made from something that is reusable, renewable, all of those things. Simply conserving. Using less of things. Why not? Recycling. Sometimes recycling makes a great deal of sense. Sometimes it only is a sound good, feel good alternative. Sometimes we use so much carbon dioxide, in other words, gasoline and such, to get our recycling to and fro. Some other better way should have been found. So recycling sometimes makes us feel good when it's not as helpful as it should be. Reusing, having a container that is used over and over again, makes a great deal of sense. Researching, we need to science our way out of this one. We need solid research. We have to find out the real from the feels good. And we also have to learn what the right way to deal with the environment is. What's the best way to ensure the earth is good for future generations? We need to educate ourselves on this, re-educate ourselves on this. Well, the problem of our day. This is a real problem the earth and its inhabitants are currently facing. This is a real problem. Above all else, the effects of this will be profound and very long lasting. We have known about it for decades, but it may interfere with the enormous wealth that is being accrued by the energy industry, Lobbyists have targeted it and supported a vast misinformation campaign. You may hear there are two sides to global climate change. Yes, there is the side that knows what it's talking about. There's the side that would like you to think that nobody knows what they're talking about. That's the two sides. Science on this is clear and has been clear for a long time. The world is changing. The climate is changing. There's not a question about that. In order to evaluate science, what science is telling you, you need to know some things. Like most of us, most scientists are good people, preferring to do the right thing and using their science to help people. A few, however, will use their science secondarily to other goals and misrepresent their science. Please know this happens absolutely everywhere in human endeavors. People treat scientists, though, as if they always know what they're talking about. Science is a serious affair. They work very, very hard to really know what they're talking about. But there are a great many scientists working different parts of different problems. So, if you want to determine what to generally believe a science is telling you, listen to the vast majority. The vast majority. Not a few outliers who disagree with the vast majority. And if you want to listen to the outliers, pay very, very special attention to where their funding comes from. If somebody is financed, deep down you look a little bit, they are financed by the oil industry to say that global climate change really isn't happening. Well, why might they be saying that? Well, they're getting paid to say that, and they like that financing. We're susceptible to that in the scientific world as we are in any other pursuit. So the way to separate fact from nonsense, look at what the vast majority of people, not people, what the vast majority of scientists and very specific scientists are saying. The scientists who we're talking about, the scientists who are versed in the science that is of concern to you. So let's talk about the scientific consent on global warming. How much does it come together? There has been great agreement by the vast majority of what kind of scientists? Oh, climate scientists. These are the ones who have something to say about it. If they're scientists from another discipline that have a PhD in a discipline that is not climate scientists, well, sure, you should listen to them. Look really carefully where they're getting their funding. Way too many of them are making some money saying this isn't happening. They're not actually climate scientists. They're not publishing papers. They're not doing the work in the field. But the people who are, the climate scientists, the vast majority of them, agree that the Earth's climate has been greatly affected by the large amounts of CO2 and methane from human activities. These are consequences that impact all of us. In a world full of seemingly more pressing issues, this problem has been ignored for ages. It's now getting harder to ignore it. As predicted, the problem is having measurable effects upon the world. So it's getting harder to ignore it. We're still doing a good job, though. So what are some potential consequences? Just a few potential consequences of global warming. By changing the timing of seasonal temperature variations, interactions get out of synchronization and may have profound downstream consequences that are hard to predict. Environmental science is complex. A flower blooms 2 weeks earlier. The bees don't come out to pollinate until 2 weeks too late. What pollinates the flowers? Okay. What happens to that species of flower? Okay, it disappears. All right, what are the effects downstream of that flower disappearing? It might disappear and nobody cares. It doesn't make any difference whatsoever. But that doesn't seem to be the way things play out in the environment. One thing does have measurable effects. Different plants and animals need different conditions. Change the conditions and you change what can survive. If you cause a drought in a vast area, a lot of things can't live there, including humans. So that can affect things. Knowing the water levels are rising. Many people and other species live near the ocean, and as sea levels rise, they will be displaced. This is vast numbers of people. This is truly vast numbers of people live close enough that within the next 100 years, it seems like they're going to have to move to places that are not expecting them. One of the others that is fairly significant here is ocean acidification. The ocean normally absorbs large quantities of CO2, and it causes the pH of the water to change as you absorb more and more. When that happens, though, many of the most fundamental forms of life, the very base of the food chain, cannot live in the lower pH. This can disrupt the ocean food chain and result in ecological collapse of the ocean food chain. This is a bad thing for overpopulated cities that rely on the fishing industry to supply them with food. Um, but it's a bad thing on levels that are hard to predict. When you collapse huge ecosystems, it causes changes. The process of nature adapting to huge changes is by changing all sorts of other things, things that we might not want to be changed. Of all of the changes, one that you have probably never heard about is the disruption of the thermohaline circulation. By global climate change, we could conceivably shut down what's known as the global conveyor belt. It moves water around the ocean over vast time periods. It provides these upwellings of water. It takes water from the surface down, oxygenated water from the surface gets down. It it changes the Earth's water. It keeps it moving. It keeps it healthy. Um, all of the world's weather depends to some extent on the thermohaline circulation. It would when you change that, when you turn that off in computer models, it throws them out the window. Nothing can be predicted with any accuracy. We've never seen anything like this. But it changes all of the models for our weather. Uh, so a disruption in these vast cycles is possible. We've seen it in the fossil record, and it's not a good thing. So global warming is a consequence of human activity. We know this to be the case. Anything that is suggesting it's not is not up with what modern science not only is saying, but has been saying for a great many decades. It's not in the science world political to say this. It's looking at the data. It's being correct. In other realms, it turns into other fights, but they're not based on good science. We must base things like this on good science. So what to do? Well, first and foremost, support science. As you grow up, remember that science, it simply is the best way we have to find real answers to real problems. Absolutely, science gets things wrong. They're one of the main human endeavors. They're maybe the only human endeavor that always clearly screams out loud when it has found that it has made an error. It works hard to find the errors. That's why it's such a good endeavor in the first place, because it is self-correcting. When you hear that science is now saying something different, it means that they have found new evidence that earlier evidence is questionable. That's why we do science all the time. We have many scientists working a problem. So when we say with confidence that something is the way it is, we are sure that is correct. You must make informed choices. Buy carefully. Eat responsibly. Vote with careful thought. You are responsible for what occurs. You may live deliberately. You don't have to follow the crowd. Live well, and the crowd may follow you. I think everybody is looking for good examples of how to live well in the world. Now, here's one of the best pictures ever. This shows the Earth for what we truly are. A lonely oasis in space. We're the only place we have. There is no other. Live responsibly.